We have 2 pennies, 2 nickels, and 2 dimes, and we're going to randomly select 3 coins from among those 6 coins. The question we're going to address is, what is the probability that the value of the 3 coins selected is 17 cents or more? Let's see what it looks like if we try drawing a tree for this experiment. We'll think about selecting the coins one at a time. The first one will be either a penny, a nickel, or a dime. The chances of it being a penny, since we have 6 coins and 2 of them are pennies, 2 of the 6 are pennies, so that's 1/3 chance the first coin will be a penny. And similarly for the chances it will be a nickel and a dime, since there are 2 coins of each type. When we move on to the second level of tree, we're talking about the second coin selected, of course. So in this case, we're looking at the first coin having been a penny, and the 3 cases where the second coin then could be either a penny, nickel, or dime. Check out what the probabilities are at this second level. If the first coin is a penny, then we're left with only 1 penny, 2 nickels, and 2 dimes. So the chances of the second coin being a penny will be 1 chance in 5. And for the nickel or dime, 2 chances in 5, because 2 of each of those type coins is left. Same logic in the other cases over here. If the first coin is a dime, then that leaves only 1 dime, 2 nickels, and 2 pennies. Things get a little tight in the third level, which represents the selection of our third coin of the 3 coins being selected. But the logic is the same. If the first coin is a penny and the second coin is a penny, then there are no pennies left, since we had only 2 pennies to start with. So the third coin would have to be a nickel or dime. Both nickels and both dimes are left, so that's 2 chances in 4 that it'll be a nickel, 2 chances in 4 it'll be a dime. Those probabilities are 1/2. If the first coin is a penny and the second coin is a nickel, then we're left with 1 penny and 1 nickel among the 4 remaining coins. 2 dimes, so that's 2 chances in 4, probability 1/2. The third coin would be a dime. Similarly, if the first coin is a penny and the second coin is a dime, we're left with 1 penny and 1 dime, which accounts for these 1 chances in 4. 2 nickels, 2 chances in 4, probability 1/2 that the third coin would be a nickel. The logic is the same all the way across the tree, so make sure that you understand what all the probabilities are, where they come from on this third level of the tree. For instance, in this area right here, we've drawn a dime and a nickel, so we're left with 1 dime, 1 nickel. These probabilities are 1/4. We're left with 2 pennies, which are why this probability is 1/2. And also, be sure you understand why there's no dime option in this portion of the tree. It's because we've already drawn both of the dimes, so the third one would have to be a penny or a nickel. There are 2 of each left. Now, in the labeling of the third branch here, I've also started thinking about the probabilities of the various outcomes. Like, take the outcome represented by this circle. Penny on the first coin, penny on the second coin, nickel on the third coin. We've talked our way through what these probabilities on the branches are, where they come from. If you multiply these probabilities together, you get the probability of this outcome, and the product of these probabilities on the branches is 1/30. But notice that sometimes you get a 1/15 probability. In this case, for instance, penny, nickel, dime, the probabilities on the branches are 1/3, 2/5, and 1/2, and those probabilities multiply out to 1/15. For all the outcomes, you either get a 1/15 or a 1/30, and I have color-coded them so that the blue outcomes at the top level are cases where the probability of that outcome is 1/30, and the red ones are like this one, where the probability is 1/15. And if you pause and look carefully at those outcomes, well, first off, make sure that you understand why each one of the blue ones is shaded blue and why each one of the red ones is colored red. Make sure you confirm what I just said about probabilities. And furthermore, notice that all the red outcomes are outcomes where we get three different kinds of coins: penny, nickel, dime, nickel, penny, dime, nickel, dime, penny. This one is dime, penny, nickel. This one is dime, nickel, penny. Turns out that all the cases where the probability is 1/15 are cases where the coins that are drawn are of the three different types. So let's record the fact that the blue-colored outcomes are the ones where the probability is 1/30, and the red-colored outcomes are the ones where the probability is 1/15. Remember what the original question was. What is the probability the value of the coin selected is 17 cents or more? I've gone through and drawn a green box around all the outcomes where that is true, where the value of the coin selected is 17 cents or more. For example, this green box is surrounding this outcome because we're talking about the outcome penny, dime, dime, which gives you 21 cents. Here we're talking about the outcome nickel, nickel, dime, which gives you a value of 20 cents. Here we're talking about the outcome dime, dime, penny, which gives you the value of 21 cents. So convince yourself that all the outcomes which are boxed in green are outcomes that fit this description, and that furthermore all the other outcomes give you a total value of less than 17 cents. For example, this outcome right here is not boxed because it's a dime, a penny, and a nickel, which is value only 16 cents. Now remember that the original question posed was, what is the probability the value of the three coins selected is 17 cents or more? I have gone through and put a green box around all the outcomes where the total amount of money selected is 17 cents or more. So check each of those green boxes and verify that that's the case, and also verify with the other outcomes that that's not the case. For example, this outcome has a green box around it because you're getting a nickel, a dime, and a nickel, which is 20 cents, which is more than the 17 cents. The outcome beside it does not have a green box around it because a nickel, a dime, and a penny is just 16 cents. Similarly over here, penny, nickel, penny is only 7 cents. But this one, penny, dime, dime, is 21 cents, so it has the green box around it. So again, verify, make sure you agree that the outcomes that do produce at least 17 cents are the ones that have the green boxes. Now, of course, when we're using probabilities in tree diagrams, the probability of any event is just, we get it by just adding up the probabilities of all the outcomes that correspond to that event. We have just identified the green boxes as picking out the outcomes that do give us 17 cents or more. So if we want to know the probability of getting 17 cents or more, all we have to do is add up the probabilities of all the outcomes in the green boxes. And those outcomes are all shaded blue, which means that their probabilities, which signifies that their probability is 1/30. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 outcomes, each with probability 1/30. So the total probability of getting 17 cents or more is 9/30. We've deduced it in this case by drawing a tree and filling in the probabilities in the tree. Now, if we're going to look for a way to solve this problem without drawing a tree, what we're going to have to do is come up with a way of describing the set of outcomes we're looking for without a tree. The event we're interested in is the event where the coin selected totals 17 cents or more in value. The key to coming up with a simple counting approach is to realize that to get at least 17 cents, one of the following things has to happen. You either have to get a dime and 2 nickels, or else you have to get 2 dimes and either a nickel or a penny. And the only way to convince yourself of that is to go back and take a good, hard, long look at that tree diagram that we just drew. So I recommend that you pause and do that. Go back and look at that big tree that we ended up with, and convince yourself that all the cases where you get at least 17 cents in value are described right here. They're the cases where you either have a dime and 2 nickels, or else 2 dimes and some other kind of coin. So we start, just as we do in pretty much every problem where we are trying to get a counting solution, we start by counting the total possible number of outcomes. Here, the situation we're looking at is randomly selecting 3 coins from these 6 coins. So if we're selecting 3 things from 6, that's a combination situation. The number of ways of selecting 3 things from 6 would be combinations of 6 things choosing 3, which is 20. So 20 is the total number of outcomes if you think of the experiment as simply picking a set of 3 coins from this initial set of 6 coins made up of 2 pennies, 2 nickels, and 2 dimes. Now, one of the cases that we're interested in is the case of getting a dime and 2 nickels. So let's count the possible ways of that happening. If we're going to be getting a dime and 2 nickels, then we have to be picking one of the 2 dimes and both of the 2 nickels. Combinations of 2 things choosing 1 is 2. Combinations of 2 things choosing both of them is just 1. So that's 2 times 1, or 2. That counts that 2 of the 20 total outcomes are cases that give us a dime and 2 nickels. So the probability of getting a dime and 2 nickels would be 2 chances in 20, which is 1/10. The other cases we need to think about are the case of getting 2 dimes and a nickel, and the case of getting 2 dimes and a penny. We can actually roll those 2 cases together. If we put those cases together, what we're talking about is getting 2 dimes and some other coin, which is not a dime. That is, it's either a nickel or a penny. So let's try to count the number of ways of that happening. How many ways to select 2 dimes and another coin, which is not a dime? For that to happen, we've got to pick the 2 dimes from the 2 dimes. That can be done in only one way. And to pick the other coin, which is not a dime, well, there are 4 other coins, the 2 nickels and the 2 pennies. So among the coins that are not dimes, there are those 4 choices, and we have to pick one of those. So we're getting both of the 2 dimes and 1 coin, which is not a dime. The number of ways of that happening is 4 different ways. That's 4 of the 20 possible outcomes. So 4 chances in 20 reduces to 1/5. So to sum up, we have just determined that the probability of this case right here, a dime and 2 nickels, is 1/10, and the probability of the other 2 cases rolled together is 1/5. So let's put it all together. These cases all put together determine all the cases where the value of the coins that we have drawn are 17 cents or more. We split it up into really what boiled down to just 2 cases, this one and these 2 combined. and found that the probabilities of each of those two cases, the first one being 1/10, the next one being 1/5, if you add those probabilities together, you're adding a tenth plus a fifth, which is 3/10. And notice that that does completely confirm our solution to the problem that we got by the tree diagram. We determined by the tree diagram solution that the probability of getting 17 cents or more is 9/30, which of course is 3/10. And here we have redone the problem by a case analysis where we've determined the probabilities. We've broken it up into cases whose probabilities we can calculate separately, and then added those probabilities together. So obviously this latter counting solution is quicker, but the only reason that this is available as a possible solution is because the problem is simple enough that we can restate the problem in terms of cases which we can count separately and then add the probabilities together. It's not going to always be the case that you can state a problem in a way where this approach is feasible. I think if you had more coins involved, you probably might not be able to construct a counting solution that's going to work for you. But on the other hand, of course, if you get more coins involved, then the tree diagram gets more complicated too.